Hi, folks. I want to provide a little clarification or, basically some answers on the AP Classroom questions from last weekend. I had hoped to get to them in class. I know some people were getting them in late, but I would like to provide that now if you hadn't figured out how to do these problems beforehand. This is 3A, and it gave you the information that's kind of shown up there, a table and an equation for G. And the first part, part A, is asking for you to get the derivative. Here's what you need to remember. It's a chain rule problem. You must remember to take the derivative of both the outside and the inside function. That could be a little harder than we thought. To take the derivative of the outside function, we're taking the derivative of f, and we don't even know what it is. The derivative of the inside function is just going to be 2x minus 1. Easy enough. But we're doing this all when x is equal to 3. So before we plug 3 in, recognize that what we have now is the derivative of f at x squared minus x. And you actually plug 3 into that equation for x. You'll realize that what you're trying to find is the derivative of f at 6 times 2 times 3 minus 1, which is 5. Plugging in the value for the derivative of x at 6 is 4. Well, now our answer here is 20. So let's take a look at part B. By the way, I just noticed that this should have been g prime of x all along because I hadn't plugged the number in until I had actually taken the derivative. So I plugged the number in here. So what it seems like is for part B, we need the second derivative of g. We'll need to take the derivative of this up here. And it looks like one thing being multiplied by another. That to me sounds like a product rule. And not only is it a product rule, it is also a chain rule again. So if we're thinking in terms of the product rule, here's the first function, here's the second function. Our derivative should be p prime times q plus q prime times p. Everything in blue right here is the derivative of this first part, and once again, we're using the chain rule. Except this time for the chain rule, it won't be f of u, it'll be f prime of u. And that was already equal to g prime there. So we've taken this, we put it all together, and of course we're going to plug in the number 0. That's going to change the game a little bit. So all I do is I plug in 0 everywhere there's an x. Where I have something like x squared minus x, that's just 0 squared minus 0. So as you can see, we have a whole bunch of different numbers. Some of them we've gotten down to an actual number, some of them we have to figure out. We plug in the value we got for g double prime, which was given. That's negative 1. We plug in the value from the table for g prime of 0. And now we can finish solving. And we have our final solution for part B. The second derivative of f at 0 is negative 5. Now the first thing for part C you need to think about, and there are two things. The first thing is, what are my boundaries here? If I'm going between C values of 0 to 3, we need to think about what that really means. Determining those boundaries comes first. Now that we know that, the second thing we need to know, and what this really looks a lot like, is the intermediate value theorem. So going back to the original problem, you have to see where they describe this as a continuous function. You must say, because it is continuous, and we have a value at 4 and 7, and 5 is between those, that there is certainly some spot where g of c will equal 5. The intermediate value theorem requires two things. It is continuous, and the y values are below and above the determined value. For 4D, now we have, 3D, we now have the mean value theorem, where we're finding the average rate of change and where it's equal to the instantaneous. But one is for f and one is for h. To solve, however, you must use a calculator. I recommend graphing. 3 decimal places.